All right, folks, so let's go ahead and continue our discussion with 2.1. We were actually, let's see, we had just talked about the average rate of change. Yeah, this was the last example we had done, and we were just beginning to introduce our difference quotient here. Okay. So as I was telling you, when we talk about the slope of a line, we always think of it on a straight line, but you can still use that same concept of slope of a line, even when you don't have a straight line. So if you look at that red line here, obviously it's a curved line, but we're still using that same concept of, rise over run. So here, basically the idea is we look at the difference between our two y values, but now that we are using function notation, we're calling it f of x and f of x plus h. X plus h is just basically you've traveled the distance from the original x value to the second one, and whatever that distance is going to be your h. So take the difference between the two x values, that becomes your denominator in the slope formula. Take the difference between your two y values, and that becomes the numerator in your slope formula. So we're basically still using the slope formula here, but now we're calling it the difference quotient. And as I was telling you last time, we did part of those calculations already when we were looking at our function notation. So we're just building up on that. So I just kind of wanted to show you how we start with the slope, rise over run. You've got your y2 minus y1 over x2 minus x1, and then translating that into our difference quotient, which is, again, all of that put together, you can still call it your average rate of change. But here, in the next couple examples, they actually just want us to find the difference quotient, right? Which means we're using this formula. So the way I like to break these guys down is actually into 3 steps. So we start by finding our f of x plus h first, then do the subtraction with the two functions, and then the last step would be dividing by h. You can do all of these as one single unit, or you can do it in 3 steps, how I'm showing you. So let's take a look, excuse me, at number 22 here. So our original function is f of x equals x squared minus 2x. So like I was saying, let's break it up into 3 parts. So for the first part, we want to start by the x plus h. Remember, again, we are finding the difference quotient, which is f of x plus h minus the original f of x function divided by h, right? So we're starting out with that first part. So remember, wherever you have x in your original function, we're going to be replacing that x with x plus h, which is what we had kind of done last time. So I've got x squared as my first part minus 2 times x as my second part. So I'm just leaving blank spaces to show you where you had the original x value. You're now going to replace those parentheses, empty parentheses, with x plus h. So we will have x plus h here, x plus h here. So what happens with that first x plus h, the whole thing to the second power? Very nice, thank you. You will need to FOIL this first part. Excuse me. Okay. So if we FOIL, what will we get for x plus h, the quantity squared? No, because remember, FOIL means take each term and multiply, right? So that would start with the first two, which is x squared. Then you would do x times h, x times h, and h squared, right? And then combine the two middle terms. Okay, so that's just on the side as scratch work. So basically, after you FOIL that first part of your x plus h function, you should have x squared plus 2xh plus h squared. And for now, I'm going to leave them in parentheses. What's going to happen here with this negative 2? Very nice. Magic words, distribute. So you're going to be taking that negative 2 and distributing it with both x and h inside, which will give us very nice. Minus 2h. And you can actually now get rid of those parentheses. So x squared plus 2xh plus h squared minus 2x minus 2h. Can we simplify any of those terms? Combine them, cancel them, any of that? No, right? Nothing is in common. Okay. So that's kind of my first step, right? Just finding the x plus h function. Now I'm going to do the numerator part of our difference quotient. So that's actually going to be where you take the answer from part 1 and subtract the original function f of x from it. So I'm just breaking it up into parts because my brain works better that way. Okay, so the answer from part 1, that's our f of x plus h function, right? So go ahead and write that down, and I'm actually going to put them in parentheses again. So that's our x squared plus 2xh plus h squared minus 2x minus 2h, right? All of that. So I'm literally just taking this part here and putting it down here. Now from that, I am subtracting, so minus sign, and I'm going to do parentheses again, your original function f of x. Now what's our original function f of x?
X squared minus 2.
Very good, yeah. The one you started out with, x squared minus 2x. I mean, you know, the parentheses in the front is just to show us that was a separate function, but the parentheses on the second part is really important because, again, we have that negative sign here, which means that negative sign is, again, going to distribute. And, you know, we know negatives changes sign, so that's why it's important to remember to distribute that negative sign. The first part will stay as it is. You can remove the parentheses now. And then distribute that negative on the second part, and what do you get? So, go ahead. Positive 2x, and the x squared will still stay negative, right? Yeah, very good. Minus x squared, and then negative and negative will become positive. 2x. Now can we simplify it? Yeah. What can we do?
You can take the 2x out.
Very good. You can take the 2x out. Positive 2x. Very nice. So again, positive 2x, negative 2x,
Well, actually,
positive x squared, negative x squared, right?
Wouldn't you?
Go ahead.
Never mind. Yeah, it's going away.
So here you can actually see it's those two terms that we brought in from our original function are actually the ones that help us cancel it out, right? And because of this minus sign here, these signs change. And because these signs change, that cancellation actually happens, you know? So there's a process to the madness, I guess. So we've canceled what we can. So let's just go ahead and write down what we're left behind with. So it looks like we've got the 2xh plus h squared, and then minus 2h. And again, I had asked you guys this question last time, but what are we seeing common between all of these terms that are left behind? Yeah, each and every one of them at least has one h, because that actually now brings us to the very final step, which is dividing by this h in the denominator. So that will be our step 3, I guess, where we take the answer from step 2 and divide it by h. So that's 2xh plus h squared minus 2h, and everything divided by h, right? If it helps you better, what you can actually do is separate your numerator. So do 2xh divided by h, keep that same sign of plus in the middle, h squared divided by h minus, and then 2h divided by h. So you're basically taking this h and dividing each term individually. So that helps you reduce each of those terms. And can anybody tell me what our final result will be after we do this division? 2x. You're missing one term in there. What happens with that middle term where you have h squared? Yeah, so we have h squared here, right? Which means it's h times h. So h times 8, which means one h cancels out and one h will stay behind. So you will have an h left over, and then like you said, minus 2. So from each of these, one h cancels out. And then whatever didn't cancel out stays behind. And your final result is going to be this here, 2x plus h minus 2. This is our difference quotient. Okay, so look through these steps and let me know if you have questions on any of them. Like I said, I'm doing this in 3 parts, but if you want to do it all together in one part, you can. There's really no compulsion on how you do it. As long as your steps are correct, your signs are correct, right? Questions? Difference quotient? Okay, so let's do a quick recap. So again, we started out with our original f of x equals x squared minus 2x function. Step 1 was actually just finding this part of our difference quotient, x plus h instead of x. So replace your x with the x plus h. For the first part, distribute that -2. And at this stage, normally nothing ever cancels out because all the terms will be different from each other. Then in step 2, when you bring in the minus f of x when you're subtracting, then this minus will actually change the signs in the function here, which helps us cancel out whatever terms you have in common. And then whatever you are left behind, each one of them should at least have one h with the term itself. So when you come down to that final step of dividing by h, one of those h's cancels out and you're left behind with what you have. Now remember what I told you, difference quotient is technically still the slope. So what you have actually done is found the slope to that original function of x squared minus 2x. Now remember, this is going to be that parabola, right? So it's going to be a curved line, not a straight line. So the idea is if you actually plug in the value of x you are starting out at, and then how far are you going to get to the second point, that distance, that's going to be your h. By plugging those points in for that given interval, you can actually find what the slope for that specific interval is going to be. Now, if you guys have to take calculus, depending on what your major is, this difference quotient leads into what we call as derivatives. Derivatives is basically, again, a new terminology for slope, average rate of change, difference quotient, and then we call it derivatives. So that's actually what this difference quotient leads into. And trust me, we did hundreds of these examples when I had to take calculus. I can sleep and probably tell you how to do difference quotient because that's what they want you to practice because it's such a crucial part of a calculus course. Okay, so if you don't have any questions, I'm going to be nice and give you the easy one to do. And I've actually changed this problem from last time because last semester we were doing square roots here instead of just 4x. So make me proud and let me see what you come up with for number 23. And I'll pause our, I don't know, is it?
Doesn't look hard.
Doesn't look hard, but you know, then you guys know how to prove me wrong. So, all right, let's look at
Hey, I got it.
23. Man, he just threw all of you under the bus, by the way. All righty. He's like, I got it right. I don't care what you guys did.
That's not what I meant.
I'm just picking on you, Jacob. Okay. So you guys are actually making it complicated, right? I guess as you're getting out of the gate, supposedly. It's just 4x, right? There are no 2x's. So I think what's confusing some of you is in this example, we had two places where you had the x, right? In this example, technically, you're actually only looking at this part because we don't even have an x squared in this example. So all you are doing is replacing where we have x with x plus h, right? So that means I originally have a 4. I'm keeping that 4 as it is, but instead of x, I'm going to replace it with x plus h, and that's it. There's no FOIL. There's no two terms that had x in it, just this little guy here. And then all you are doing is taking that 4, yeah, and distribute that, which gives you the 4x plus 4h, and you're actually done with that first part. That's it, right? Then the second part was the numerator part of our difference quotient, which is where we bring in the subtraction. So we take this answer from part 1 and subtract the original f of x function, right? So write down what we got here, which is the 4x plus 4h. Now this is our first part. Then you are doing minus, yeah, the original function f of x, which is only 4x, which means you are subtracting the 4x from that first part. And anything cancel out at this point? Yeah, your 4x will actually cancel each other out, leaving you behind with just the 4h, right? Hiram?
Yeah.
You sure?
Yeah.
You kind of had this look of, I don't know what happened.
Yeah.
Okay. Anybody else? Okay, and then the last step was taking this answer, divide by h, which gave us, there you go. Is the h and h cancel out? Okay. Questions on 23? All right, I'm gonna try this one more time, folks.
Have you seen Billy Madison? Got any more framed?
I have seen like bits and pieces, but so one more try, people. Let's try 24. Okay, and I've changed 24 also. It used to be a fraction, but now we're just giving you a straight line here. So let me see, negative 2x plus 3, what will be your difference quotient for this guy? Negative 2x plus 3. Little confusion on some parts. Okay. First part we do here is again. What's that?
The hack of the system here.
Okay, go ahead, tell me.
That equation is in mx plus b format.
It is.
So your slope is -2.
Yeah. Yeah, because the first quotient is the slope. Look at that. See? Good way to check, right? You still got to show your work, though.
Oh.
He's like, man, I thought I could just skip all of that. Alrighty, so we start by replacing our x with x plus h, and then distribute that -2 with the x and h, and you end up getting -2x, -2h plus 3. Step 2 is where we take this answer and subtract the original function from it, right? So -2x minus 2h plus 3 will stay as it is, and then we're bringing in minus of the original function, which is again -2x plus 3. And this part I do like to put in parentheses so that I remember we need to distribute that negative sign, right? So first part will stay the same. Negative times negative will become positive. Positive times negative will become negative, which is what we want, so that we can cancel out the negative and positive 2x. positive and negative 3, and what is it, just negative 2h? And remember, this is the step where I was telling you, you should have at least one h left behind in your remaining terms. And then the last part, divide by h. When we did the x plus h, yeah, we brought it in. Very nice. Okay, so did you guys hear what Jacob and Christian were talking about? Okay, who wants to say it, but really loudly?
It's in
Paper,
MX.
scissors for it. Rock, paper, scissors for it.
No, Jacob is saying.
It's in MX plus B form. So the term in front of the x on the original equation is your slope.
And you're calculating the slope, right? So he's saying this equation is given to us in the y equals mx plus b format, or f of x equals mx plus b format. So that's my mx plus b. So your slope, you can see, is -2. So when you go through your difference quotient calculation, you should get that same -2 as your answer, which is actually the same case in the previous example where you had 4x, because that was also mx plus b, where your b happens to be 0, right? So that's why, again, your slope was 4. You should get 4 as your answer. Okay, very good. Unfortunately, that same logic does not work on that first example where you had the x squared, because for a square function, it's not the mx plus b format, right? All right, nice job, guys. And, oh, looks like that is it. Yes?
There's no one of these. I'm like not super confident.
You're not feeling confident?
Not really.
Not really? Okay.
More is better.
Give me a function.
F of x 3x plus 10.
Where's your function?
3x cubed. That's 9.
Sure, I think I like that better. You know, no, let's not do cube. You'll take forever to foil that. We'll be here till eternity.
To the power of 10. To the power of 1,000. That would be bad.
Yeah, we'll definitely be here for an eternity if we try to do that by hand. Steps. Brian, what about you?
Amazing.
3, yeah.
All righty. X plus 3h plus 10. Keep that part the same and then subtract the original. So the negative will distribute. What terms cancel out here?
The
Very
3x
good.
and the 10.
And then all you are doing is 3h divided by h, right? Alrighty, very nice.